Hello everyone, this is Vishwesh and we are in the series of videos on aptitude skills. In this video we are going to talk about the important topic which is time and distance. Now in this video we are going to see the logic of time and distance, how exactly these two are related to each other. And obviously we will have practice questions on low, medium and high difficulty level questions. Let's start with the logic. Basically, time and distance, these two terminologies are related with each other with respect to the third terminology, which is speed. So we all know the formula speed is equals to distance upon time, and this is applicable for every question. Let it be any question, this formula will be applicable. This logic will be applicable. So what this logic says, when there is a vehicle and this vehicle is passing or running with the speed of 80, what do we say? The vehicle has passed with the speed of 80, and this 80 is having unit as kilometer per hour. So basically it is 80 kilometers per 1 hour, which is nothing but 80 kilometer per hour. So within 1 hour the vehicle is covering the distance of 80 kilometers. Similarly, within 2 hours, this vehicle will pass on or will cover 160 kilometers. Within 3 hours, it will pass on 3 times, which is 240 kilometers, and so on. Correct? Similarly, within 0.5 hours or 30 minutes, it will cover up 40 kilometers, and this way also we can deduce it. So this is the logic. Speed is equals to distance upon time, and from these three terminologies, speed, distance and time, from these three terminologies, maybe in the question, in the aptitude question, maybe two terminologies will be given and we have to find out the one which is missing. Okay, merely all the kind of questions are like this only, and provided in addition, I will say in addition, there is a tricky logic is there, and that we have to understand. Now let's start with the questions. Here we have first question of low difficulty level. A car traveling at a speed of 40 km per hour. So speed of the car is given, can complete a journey in 9 hours. So time is also given, and then full stop is there. So distance is missing in this. Then second condition is how long will it take to travel the same distance. So distance is same, we can consider this same d at 60 km per hour. So speed is given and now time is missing in second case. So there are two cases, case 1, case 2. Let's talk about case 1. So in case 1, d is unknown, that we can write as question mark. Speed is given as 40 km per hour, kmph I will write down, and time is given as 9 hours. So simply we can apply the formula speed is equals to distance upon time. Speed is 40, distance we have to calculate, time is 9. So distance will be 9 4s are 36, so 360 kilometer is the distance. Now in case of second case, case number 2, what things are given? How long will it take to travel the same distance? So distance we have to consider same, which is 360 km. So this term is given. Then speed is also given 60 km per hour. So speed is equals to 60 km per hour, and time we have to calculate. So let's write down the same formula. Speed is equals to distance upon time, which is 60 is equals to distance 360 upon time t. And hence t will be 360 upon 60, and this 0 we can cut, 6 1s are 6, 6 6 are 36, time is 6 hours. So time required to travel the same distance with the speed of 60 km per hour will be 6 hours, which is option 1. Option 1 is correct. Let's go to the next question. Now this is of medium difficulty level question, little tricky, and you can pause the video over here and try to solve it. If not possible, you can go through this solution. So what is the question? A boy goes to his school from his house at a speed of 3 km per hour. So while going to school the speed is this, and while returning the speed is this, 2 km per hour. If he takes 5 hours in going and coming, so combine while going and while coming, total time is 5 hours combined time, then the distance between his school and his house is what? That we have to calculate. So let's consider that this is the house of that boy and here we have the school. So while going and while coming back, these are the two cases. So while going he is having the speed of 3 km per hour, while coming back the speed is 2 km per hour. Correct? Now for these two travel journey, the time, combined time is 5 hours. So let's assume that he took x hours for while going, so while coming back it will be 5 minus x. Correct? And from school to house and from house to school, this distance will be same while going and while coming back, although I have shown the arrows different over here, but the distance is going to remain same, it will not change. So we can consider again the same formula, speed is equals to distance upon time. This we can modify a little bit, I mean we can rearrange the terms. D is equals to S into T, we can send this T to this side, that will make it distance is equals to speed into time. Now here distance is common in both the cases, while going and coming back distance is common, we can equate with it. So while going the speed is 3 km per hour, let's write it down. 3 into time is x is equals to, while coming back the speed is 2 while time is 5 minus x. Correct? Let's simplify this. So 3x is equals to 5 to the 10 minus 2x. This 2x we can bring it on this side, so 5x is 10 and this gives x is equals to 10 upon 5 which is 2. So 2 is what? X is what? Time. So here 2 hours we can say, x is 2, so 2 hours while going and while coming back it is 3 hours. Correct? Now for the remaining part of the question, now what we have to calculate? We have to calculate the distance between school and his house. That we have to calculate. So we can use any term, either we can use the while going or while coming back. Now while going it is speed is equals to distance upon time, same formula. Speed while going, speed is 3 km per hour is equals to distance we have to calculate, and time it is 2 hours. So distance will be 3 to the 6 kilometers. Same we can consider for coming back from school to house. While coming back, speed again the same formula, it will be speed upon speed is equals to distance upon time. While coming back speed is 2 kilometers, distance we have to calculate, and time is 3. So again here we get distance is equals to 6 kilometers. So in both the cases we will get the same answer, and that is correct. First option is correct. Let's go to next. Now this question is of medium difficulty level. Let's read the question first. A car driver leaves Bangalore at 8:30 am and expects to reach a place 300 km from Bangalore at this. Now expects is written. Now he hasn't reached that place at 12:30, but expectation is there. Correct? Now in between at 10:30 he finds that he has covered only 40% of the distance. Now expected is what? Since 8:30, 10:30 and 12:30, it is the mid time. We can draw it like this. Let's say this is 8:30 am. In between it should be 10:30 am, and at the end it will be 12:30. So everywhere we can see 2 hours. 2 hours is the gap. 2 hours is the gap. So if the driver is leaving Bangalore at 8:30 and if at 10:30, after 2 hours, that is half of the time, he should have covered 50%, but he has covered only 40%. 40% of the distance is covered and still 60% is remaining. and he has only 2 hours in his hand, correct? So he needs to increase his speed. He needs to increase the speed, or else he will get late to reach at the destination at 12:30. He has to increase the speed. There is no other option than to increase the speed. Now question is, by how much he has to increase the speed of the car in order to keep up the schedule, keep up his schedule. Now what we have to find out is, from this 10:30 till 12:30, or for remaining 60% of the distance, how much the speed will be, or how much he has to increase. So to find out the increase in the speed, we have to first find out the how much speed it should be. Now what is given? The distance between these two, this distance and this point and this point, the distance between these two is how much? It is already given, which is 300 kilometer. So this is 300 kilometer, correct? And 40% of the distance is covered. So this 40% will be equals to what? 40% of 300, which is 4 3s are 12. So 120 kilometers he has covered till 10:30. And from 10:30 to 12:30, remaining 60% of the distance, which is 180 kilometer, is still pending. It has to be covered still. Now to cover up 180 kilometers in 2 hours, what will be the speed? Speed is equals to distance upon time. 180 upon time is 2 hours. So this should be 90 kilometer per hour, kmph. This should be the speed of the car from 10:30 to 12:30. But question is, how much he has to increase the speed? So already there is some speed of the car and he has to increase the speed. So how much he has to increase? So this 90 is not the final answer. Now from 8:30 to 10:30 he has covered 120 kilometers. So this speed is what? 120 upon, in 2 hours he has covered. So 120 upon 2, which is 60 kilometer per hour. So for half of the journey, or half of the time, he has 60 kilometer per hour, and for remaining half he needs to maintain 90 kilometer per hour. So increase in the speed is 30 kilometer per hour. So this should be the final answer, which is option 4. Option 4 is correct. Let's go to next question. Now this question is of high difficulty, but believe me, this is not that difficult question. It is little tricky. Once you understand the trick, once you understand the logic, this question is also very easy. So I will suggest learners to pause the video and please try to solve it on your own. If not possible, you can go through this solution. A thief is noticed by a policeman from a distance of 200 meters. The thief starts running and the policeman chases him. The thief and the policeman run at the rate of this and this respectively. What is the distance between them after 6 minutes? Now this is little tricky. After 6 minutes, what will be the position? Okay, that we have to find out. Now here few things we can clear. Let's say this is the policeman. Here we have the policeman and here it is the thief. Let's say this much is the distance, thief and policeman. When policeman sees the thief, obviously policeman will start running towards the thief and thief will start running away from the policeman. In short, both policeman and thief will have parallel running line, parallel running, and maybe towards this direction. Both will run towards same direction. I mean, both of these, policeman and thief, will not run in opposite direction. They will be running in the same direction, correct? This is one thing we need to clear. Second thing, the distance between these two, thief and police, is 200. So we can write it down here, 200. The policeman is having the speed of 11 km per hour and the thief is having the speed of 10 km per hour. So within 1 hour, policeman will run 11 kilometers. Within 1 hour, thief can run 10 kilometers. That is what the speed is given. Now instead of hours, we have to talk about minutes. So we need to convert it. So we can write it down over here again. So speed speed of policeman is 11 kilometer per sorry, let me erase this. Just a second, let me erase this part, it will confused. Now here what we can note down is policeman is running with the speed of 11 kilometer per hour. So given speed is 11 kilometer per hour, and thief is running with the speed of 10 kilometer per hour. So given speed is 10 kilometer per hour. Since we have to talk about 6 minutes, so we can convert this kilometer per hour into kilometer per minute. So how we can convert? We just have to convert hours into minutes. So that will be 11 upon 60 kilometer per minute, and this will be 10 upon 60 kilometer per minute. Correct? Now we have to talk about after 6 minutes what will happen. So here we can write it down, after 6 minutes. Correct? After 6 minutes what will happen? After 6 minutes the policeman will have would have covered 6 into 11 upon 60 distance, and the thief might have covered 6 into 10 upon 60 distance. Now when we solve it, 6 we can cancel, so it will be 10, 11 upon 10, which is 1.1. So this will be 1.1, and this calculation will be 0 0 we can cancel, 6 we can cancel, and 1. So policeman will cover 1.1 kilometer, whereas thief will cover 1 kilometer after 6 minutes. Now initially they were having the distance between them as 200 meters, but after 6 minutes this will be the distance covered by policeman and thief. So this distance, the difference is 0.1 kilometer. This difference is 0.1 kilometer, which is 100 meters. And out of 200, if 100 meters are reduced, then remaining will be 100 meters. And this should be the distance remained, or the distance is still to be covered after 6 minutes. So option 1 is correct here. Let's go to the next question. Now this is a high difficulty level question. I will request all the learners to please pause the video and try to solve it on your own. A boy started from his house by bicycle at 10 am at a speed of 12 km per hour. His elder brother started after 1 hour 15 minutes. Okay, at 10 am the boy started, and after 1 hour 15 minutes his elder brother started by scooter along the same path and caught him at 1:30 pm. The speed of the scooter will be what? The speed of the scooter in kilometer per hour will be what? Now in this, first let's talk about a boy. Let's say here the boy has started, and from this point let's say he has finished at this point 1:30 pm, and this time is 10 am. What is the time from 10 to 1:30? So total time is from 10 to 12 it is 2 hours, from 12 to 1:30 1.5 hours, or 1 hour 30 minutes. So total time will be 3.5 hours. The boy has taken 3.5 hours to reach this point at 1:30 pm, and the speed of the boy is 12 km per hour. Now speed is given and time is also given. What we can calculate? Distance. Correct? So speed is equals to distance upon time. This formula we already know. Now speed is given, which is 12 km per hour, is equals to distance we have to calculate, and time is 3.5. So distance will be equals to what? So this distance will be 12 3s are 36 plus half of 12, which is 6. So this distance is 42 km. So basically this distance is 42 km. Now next let's talk about now elder brother. Now in case of elder brother we can consider a green ink. In case of elder brother, he started after 1 hour 15 minutes. So instead of 10 am now the time is 11:15 am. At 11:15 a.m. the elder brother started and he has covered the same distance. Correct. Now we know the starting time, we know the ending time. At 1:30 p.m. he caught his brother, correct, on scooter. So we know the starting time, we know the ending time. What is the time lapsed? So from 11:15 am there will be 45 minutes till 12, and from 12 it will be 1 hour and 30 minutes. So the addition of all these three will be total time, that will be 2 hours and 15. So 2.25 hours, correct. 2 hours and 15 minutes, in decimal it can be 2.25 hours. Now we know the distance 42 kilometer, we know the time taken by his elder brother, we can find out the speed. So speed is equals to distance upon time. Distance covered is 42 kilometers divided by time is 2.25. Simple. Now let's remove this decimal, so we can multiply 100 in numerator and denominator, so it will be 4200 upon 225. Now looking at these two zeros and here also 225, let's start dividing by 25. So here 25 8s are 200 and 25 9s are 225, and here it will be 25 25 ones are 25, and what is the remaining? It will be 5 and 10 15 and 17 170. So 25 6 are 150, and what will be remaining? 170. 25 6 are 150, so still 20 is remaining, 200 it will become, and 25 8s are 200. So remaining figures are 168 upon 9. Again we can divide by 3. 3 1s are 3, sorry 3 3s are 9, and 3 5s are 15, 1 is still remaining, and 3 6s are 18. So it is 56 upon 3, and 56 upon 3 we can still divide it because the options are either in decimal or in fraction. So let's again divide it. 3 1s are 3, here 3 1s are 3, 2 is remaining, 3 8s are 24, and still 2 is remaining, which will be 2 by 3. So final answer should be 18 2 by 3. 18 2 by 3, which is option 3. Option 3 is correct. See, so even though this question was really tricky, but still the same logic, speed is equals to distance upon time, and same kind of trick we have used, logic we have used, and we found out the answer. Let's go to the last question now. Now this question is really very tricky. It is a difficult level question. Why it is tricky? Once you read it and once you start solving, you will understand. So I will request all the learners to please pause the video, try it on your own, and if not understood or if you are not able to get the answer, you can check it here. What the question is: two trucks A and B are traveling on a highway opposite to each other. So these two trucks are traveling opposite to each other. Let's consider this is the distance. Let's say here we have truck A and here we have truck B. These two trucks are there. This truck A is traveling in this direction, truck B is traveling in the opposite direction of truck A. This is given, and speeds are also given, 60 and 80. Let's say this is having 60 km per hour speed, and this truck is having 80 kilometers per hour. The speeds are also given. Now there is a flying B which started flying from truck A. Let's say here the flying B is there. Let's say this is the flying B which started from flying from truck A towards truck B. So this flying B has started from truck A towards truck B at the speed of 120 km per hour. The speed of this flying B is very high, which is 120 km per hour. And the flying B has started flying when the distance between two trucks was exactly 280 km per hour. So this distance is 280 kilometers. Sorry, 280. Okay, 280 kilometers is the distance between these two trucks, and the flying B has started. When flying B reaches truck B, after flying some distance, now this truck will be coming nearer to truck A. This distance is going to reduce every second. After some time, this truck B may be at this point. This truck B may be at this point, and at that time when the flying B reaches over here, the flying B takes the U-turn. It starts flying in the opposite direction again towards truck A. It has started again flying towards truck A, and this goes on. When the flying B reaches truck A, the truck A might have covered this distance, and when the flying B reaches truck A, again it changes its direction and again starts flying towards truck B. Meanwhile, truck B might have covered this distance, and again when the flying B reaches truck B, it again changes its direction and tries to fly towards truck A. So this reciprocation, we can call this as reciprocation. This reciprocation continues. This reciprocation continues till both the trucks meets face to face. Both truck A and truck B, when they meets face to face in one line only, then we can stop, or the flying B will stop flying. Correct? So this is the situation, this is the given condition, and what the question is, how much is the distance covered by flying B during this reciprocation? How much is the distance covered by flying B during this reciprocation? Now to calculate the distance that is to be covered by flying B, what formula we have? Speed is equals to distance upon time. This is the formula. Correct? Let me change the ink now so that there will be no confusion. The formula is speed is equals to distance upon time. Same formula. Correct? Now in this, since we have to calculate the distance covered by flying B, speed we know. Speed of the flying B we already know, which is given 120 km/h. Distance we have to calculate, and time we should be able to calculate. Time we have to calculate from the given condition, then easily we can calculate the distance by using this formula. Correct? Now from position this of truck A and position of this of truck B, the distance between these two is 280 kilometers. These two trucks are 280 kilometers apart, and then flying B has started flying towards truck B, and then truck A, truck B, truck A, reciprocation continued. Now here the major part or the major logic hint is truck A and truck B both are running in the opposite direction, which is already given here. Both are running in the opposite direction. Now from this position to 280 kilometers apart, from this position till they meet each other, when they meet face to face with each other, this time we have to calculate. Correct? And that can be calculated from the same formula, speed is equals to distance upon time. Now here, since both two trucks are there, both the trucks are having different speeds, 60 and 80, we can consider the relative speed over here. We have to consider the concept of relative speed, and this relative speed concept we already have tried to cover in the topic of train related questions. You can check that video. So relative speed we have to use. In the relative speed, when both the trucks are running in the opposite direction, their speeds will get added. So 60 is the speed of first truck, A truck, and 80 is the speed of another truck. This will get added. Distance we already know, it is 280 kilometers, so that we can write it down here, 280 divided by time. We can calculate the time. So from this we will get time, which is T is equals to 280 upon 60 plus 80. 60 plus 80 is 140. So this 0 we can cancel. 14 1s are 14, 14 2s are 28. So time we got 2 hours. So 2 hours is the time taken by truck A and truck B to meet face to face and covering the distance 280. Correct? So the same time we can consider over here, because during that time the flying B will reciprocate. within 2 hours the flying bee will reciprocate. So speed of the flying bee is what? 120 is equals to distance we have to calculate, and time is 2 hours. So distance is equals to 12 to the 24, 240 kilometers. So flying bee has covered the distance of 240 kilometer, and that is the final answer. So this is how, even though the question was very tricky, but by using the same concept, speed is equals to distance upon time, same logic, we are actually able to cover up and solve this question. So at the end I will say that there is only one logic for this topic, speed is equals to distance upon time. So actually there are two topics under this same logic. First one is the time and distance questions, which we are discussing the same topic, time and distance, and second topic is train related questions, which is very famous topic for all the tests, train related problems, and both these topics will have same logic, speed is equals to distance upon time. So I will request all the learners to please practice as much as possible for this topic, and that will make you confident in this topic. So let's end this video over here. Thank you.